welcome you to the 14th International Conference, Confluence 2024, Cloud Computing, Data Science and Engineering, organized by the Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated to its responsibility of imparting its students a strong foundation and platform for empirical inquisition. With this agenda, Confluence 2024 intends to bring together professionals, academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovations, share research results, and new directions in the field of next-generation technologies. On behalf of Amity University, Noida, we welcome a visionary leader and our speaker for today, Ms. Susanna Barnes, an accomplished data governance professional with over 8 years of experience developing and implementing information and data governance policies, emphasizing metadata management and knowledge management. She is an experienced product owner with a focus on automating data governance, leveraging Elation. Her experience includes leading a team to implement the data catalog across multiple operating companies and business areas, operationalizing and automating data governance policies, managing and customizing a metadata repository, and implementing data classification, best practices, and procedures. She is currently working on providing opportunities for the next generation of data leaders to get hands-on experience with enterprise data management tools in the classroom through Elation's Data Intelligence Project and leading the development of Elation Help Center. She is a luminary whose expertise and insights have left an indelible mark on this field. And today, we are privileged to have the opportunity to glean insights from this remarkable individual about data intelligence empowering the workforce of tomorrow. Now, I request Ms. Susanna Barnes to kindly address the gathering with her words of wisdom.
Thank you so much for that very kind introduction. I'm very excited to be here today. I appreciate the opportunity to speak to you and the invitation. So as I mentioned, I wanted to just give a little background about myself. I don't think I can do a better job than you just did, but just to hit on a couple of high notes that I'd like to point out. I have worked in the data governance and data enablement space for several years, 8+ years now. Currently, I work in a program management role for the Elation Data Intelligence Project and the Elation Help Center. One of the reasons I ended up at Elation in the role that I'm in right now is that I started work in a large property and casualty insurance company right out of graduate school. I have a master's of library and information science. So as I was leaving my information science program, I was looking for less traditional type roles for that library and science degree that I had earned, and ended up working in metadata management. My specialization in school was information organization. I was very interested in taxonomy, ontology development, metadata management, best practices and things along those lines. So as I was working in the data governance and metadata management space at the company that I was at, American Family Insurance, I really came to understand that there was a lot of gaps in the training that I had gotten in school. And there were a lot of opportunities to help people understand and learn how data has to be treated as an asset, much like you would treat the kind of information that you would catalog in a library, whether it's a database of articles, or whether it's books, or whether it's digital recordings. The same practice and expertise can be brought to those types of digital assets as well, those data assets. And so as we were looking for a new tool, we ended up selecting Elation. And after I used it for a couple of years, I found a lot of synergy between the way it was designed and developed and the kinds of practices and theory that we had learned in school as far as information organization and best practices and things along those lines. So I reached out to our account team and I asked them if they would ever be willing to offer their software for use within colleges or universities. I knew that my alma mater, the School of Information Science at the University of Wisconsin-Milwaukee, would be very interested in adding that as a component to some of their classes. They agreed. Fast forward 3 or 4 years later, it's a formal program now, and so I joined Elation to lead that program. And one of the core reasons why Elation feels strongly about this program and the need for this in the workforce right now is that our core mission is to empower a curious and rational world. We want people to understand data. We want people to be data literate. It just as, you learn to read data the same way you learn to read books, the same way you learn to look at art and interpret visual images. It should just be something that, as we have this more data driven and digital world that we interact with, it should be another core competency that everybody has access to. And so we looked at the workforce, and we recognized that there were gaps, and there are things that we felt like we could do to kind of help start to develop some of that data competency within people that are in college and university programs who may not necessarily be planning to become a data analyst or planning to become a data scientist. So there's a lot of supporting roles. There's a lot of other types of roles around those data project type roles that need to be developed. And we need the skilled data workforce now. Everybody sort of understands, I mean, the nature of your conference makes it clear that the need for data science and AI practitioners is just growing and growing and growing exponentially. In the US alone, there's over 1,000 academic programs focused just on data science or AI, and that's just one small slice of the world. The job outlook for this role will grow over 22% for the next decade. And it just keeps growing and growing more each year. Companies have to compete for that talent. So if you want to attract talented data scientists, if you want to attract talented data engineers, you have to demonstrate that you're committed to building an internal data community that will support them. You have to focus on the development of a modern data ecosystem, make sure that you have modern data tools that work well together so that they can do their job easily, they can take advantage of the new advances in their field. And you need to make sure that they have high quality, well-governed data sets that are accessible to them so that they can do their job easily. They can get access to data that's a fit for purpose and appropriate for their use. And the reason for this is that to maximize the value of organizational data, companies have to reduce the time it takes for data scientists and data analysts to find the data they need and put it to use. Right now, there's a number of different estimates. Currently, the most common estimate that you might hear in some of the reporting and stories is that analysts, data scientists, they spend up to 80% of their time cleaning and organizing data before they even get to the point of being able to use it. That significantly impacts their productivity. It significantly impacts the results and the analysis and insight that they're able to provide for their organizations. And so we hope to start working with companies and with colleges and universities to identify how to kind of train those ancillary roles that help support these data ecosystems. So we all know about the technical roles. There's data engineers, there's machine learning engineers, cloud engineers, data tool administrators, but there's knowledge roles too that are critically important as well. We need governance specialists, we need data stewards, we need data librarians, people who can curate and catalog data. We need people who are in leadership positions who just know how to make data-driven decisions. They know how to find data and understand when data is fit for what they need. And this is really important for companies to grow and compete for that talent. So those really high value data specialists, the data scientists, the AI specialists, they need to feel supported, and they need to feel like they can focus on what they need to do, what they've been hired to do, instead of doing other things like curating and managing data. But it's really important to point out that this knowledge that's generated and curated and captured about data, it can't really just be put into a repository. We're not talking about a static catalog. We're not talking about something where you just go look something up. It's an interactive, it's a dynamic system that has feedback, it grows, it changes over time. And so it really is more of this data intelligence platform that we're talking about. So why does data intelligence matter? It matters because it's foundational to some of the core things that everybody needs to work towards in order to develop data cultures within their organizations and within their practices. So you have to be able to support self-service analytics. People have to be able to go and get the data they need themselves and understand which data they should be getting. You need to take advantage of the cloud technologies so that you can easily shift data from one place to another, so that you can take advantage of where you get the best value for your compute when you're training models, where you're doing different types of processing. You have to be able to use the cloud to its best advantage. And you have to be able to apply data governance to those data assets and those systems, not just at the final point of data where people are picking it up and using it, but throughout the entire data lifecycle. These things all together are built on that foundational data intelligence understanding within the data intelligence platform, and that helps drive your data culture. Just to give some examples, so self-service data, can everybody find easily and understand the data so that they can take it and use it as rapidly as possible. When you're looking at that cloud transformation piece in the middle, is the data, do you have it placed in the optimal storage setting? Do you have it placed in the right type of processing system? Can it easily be shifted from one place to another through some kind of an automated process, or does it require manual intervention for someone to go and move it from, an archive storage to a rapid use storage for certain processing tasks? And can you enable everyone to use the data the right way and maintain compliance with all of the privacy concerns and compliance standards that exist? So by connecting to everything, making sure that everybody's adopting the platform and understanding what the data intelligence platform is from, you also are able to insulate consumers from shifting architecture. So you're building a semantic layer of knowledge and information about your data that helps people find what they need, but they don't necessarily have to worry too much about whether it's in the Google Cloud Platform or whether it's in AWS. They just know that this is the data set that's right for what they need, and they can get to it and they can use it. And so one of the key ways to accelerate data intelligence that I mentioned earlier is to make sure that you've built in data governance and awareness of data curation, data content, data information management throughout the entire life cycle. And a lot of times when you're talking about sharing information about data, people might start to think about it as sort of a documentation task, like, oh, we have to do the data dictionary, we'll do it after the project's done. There's a lot of concern sometimes that documentation can be set aside, it can be done later. But what's really critical is making sure that you're capturing that information at the point that it's created. So when people are gathering requirements, data requirements for a new data product, that's critical information that needs to be captured. And you need to capture it in such a way that you can then structure it as metadata and use it to activate processes later on. So you don't want to just document things for the sake of documentation. You want to build structured information frameworks so that that information can be activated and leveraged for automation later on. And that starts to build that governance workflow throughout the entire data lifecycle. And it really helps you deliver that data and information at the point of use. People can get faster, trusted, higher value data insights. So what seems like maybe when you first start thinking about it is, oh, we need to document our metadata, we need to put it in a repository. You're really building in, a connected system of information and a connected approach to data governance that will deliver a lot of value later on in your processes and allow you to automate things after the data has been delivered. So some examples of that. If you have a data intelligence platform, the information is captured, it's organized for optimum use by both humans and for automation. So you can capture information from the spreadsheets that the requirements are gathered on. You can capture it from the code itself. You can capture it from the README docs attached to your model code. And doing that in an automated way, mining those sources for valuable information, applying some semi-structured standards to those sources as they're created. It allows you to take that information and insert it into your data intelligence platform with minimal effort once those frameworks are in place. That helps you deliver the information using that metadata later to the right people. They can filter, they can search across it, they can get meaningful insights from it, and easily find what they're looking for. The second section here is kind of that governance piece, the documentation of policies, the definition of metrics, doing that in a centralized location instead of doing it in different areas throughout an organization. It allows you to have consistency across the entire data landscape instead of applying governance to one data set or another, one silo or another, one part of the business or another. And not only that, but you want to document those policies in a way that they too can be activated. So they're easily activated and monitored in ways that you can automate your governance processes so that something can't go into production if it doesn't have all of its metadata also created and uploaded. Like, what kind of checkpoints can you put in place so that your policies are adhered to in a meaningful way? And ultimately, even though it might sound like you're adding a lot of red tape and a lot of roadblocks early on in the process, this will ultimately empower users and allow them to get to the data that they need much more rapidly because the controls are already in place. The roads are already built. People know what exit to take. They know which speed to go. All of these guide rails are in place so they can rapidly kind of go down this path and get to the data that they need as quickly as possible. And that reduces the time to value and really creates value from the data that's being delivered. So what does this, maybe look like a little bit in kind of a system? So if we look at this connected governance and action slide, and we start maybe at the top left, that's the data product documentation I was talking about a little bit. So I'm working on a data product team. We're gathering the data attribute list. We're gathering the data requirements. That's kind of the business metadata, right? So we can pass that information back into the data intelligence platform. So we know the key business questions. We have sample queries associated with the data that's going to be delivered that answers those key business questions. And then coming down to the bottom off of that, you have the code, you have the actual technical information that's building the data sets within the data sources. You have the delivery pipeline, and automated checks are built into that delivery pipeline to make sure that the data types are consistent, that everything's appropriate. You can have metadata-driven security architecture assigned to your data sets too. Maybe you've done data classification on the raw data. So as things are built, they're automatically slotted into the right security architecture based on the metadata that's captured in that business data product documentation. These data sources will then feed technical metadata into your data intelligence platform. So you have business metadata coming in one channel, technical metadata coming into another, and the platform synthesizes that information into one location for users to search across. In addition to that, your stewards and your governance teams can provide more complete metadata, right? They can provide insights that are derived from the data. They can link to workbooks. They can link to BI reports and things like that. And they can start to assign policies and classifications to the data too. So they can define those policies in a centralized place. And then if you have a system of data services that are running against your data sources, those can all draw from that global set of policies that are defined. So it doesn't matter if somebody's doing an ad hoc classification task, or if they're running a regular data discovery task across all of your systems, they're going to look for the same classified policies, and you can apply them the same way. So this is your personally identifiable information, your privacy law regulations, depending on where you're living. You don't have to worry about who's doing that classification work because the policies are globally available, and the rules and the standards for applying them are globally available. And these services, again, will also create their own form of metadata that can be fed back into the data intelligence platform. And you really start to get that really complete, robust set of information and metadata about the data that you need to use for your delivery. So this probably makes, a fair amount of sense for a more traditional kind of standard data environment that we've lived in up to date. But what I kind of want to do now is take a step back and say, well, that's great, but not everything's relational databases anymore. We have a lot of other things that are happening. We have generative AI, we have machine learning that's, it's ingesting data from multiple sets, and it's actually creating new data sets, not necessarily in the same way that they've been created in the past. So how does this apply to that type of environment? There's a lot of pressure right now to figure that out, right? There's a high demand for AI applications throughout organizations. Just a few numbers that we can share about that. 64% of CEOs say that they have significant pressure from investors, creditors, lenders to accelerate adoption of generative AI. People want to go fast. They want to see results. They want to use the most cutting edge, newest advances. And they don't want to slow down for things like data governance or data safety or data protection. Over 55% of organizations are currently experimenting with generative AI. By 2025, the estimate is it will play a role in 70% of text or data heavy type tasks. So there's clearly a need to make sure that we're still applying the guardrails to the data that we're using, but there is not an appetite to slow down and figure out new ways to do that. We're really seeing an unprecedented shift in how generative AI is driving advancement. It's literally changing the way we work, produce, and consume information. So we have to figure out rapidly how we're going to approach this problem. And that, there's good news and there's bad news, right? 4 out of 5 executives see at least one trust-related issue as a roadblock to generative AI adoption. And some, this includes privacy, it includes data accuracy. In a way that's good. I mean, they recognize that there's a problem, that we can't necessarily just jump off the cliff and hope for the best. And to dig in a little bit more into this kind of a statement, a lot of the problems that they're calling out and the problems that they're seeing are not that different from the problems that we see in data itself. So there's issues with data availability and data quality. There's a lack of trust in the data. There's a lack of cross-team collaboration. Data is being delivered in silos. There's GDPR compliance, security issues, and the general concerns there's a lack of a data culture. So the same problems that people are concerned about with the adoption of AI and machine learning more broadly within their organizations are the same problems that people are concerned about with data in general. And so we can approach them in some similar ways. And so that's going to help us kind of start to put some ideas around how we might tackle this problem. Because if you're looking at the challenges of the current AI workflow, people need to find their data. They need to know, where it is, what's available. Is there enough of it for me to train my models appropriately? They have to be able to trust the data. Is it a clean data set? Is it stuff that I'm allowed to use? Is it, is it trustworthy for me to train on? How do we understand what data sets models have been trained on? Like where's the trust factor? How do we understand that insight and know what's going on there? And then they have to be able to govern it. So how do you safeguard against proprietary and sensitive data being used for training in models? How do you safeguard against exposing information that you don't want to expose as you're put in the outputs of your models? How do you govern how people are using them and making sure that they're using them for appropriate purposes? So the good news is data intelligence will work there as well, right? The principles are fundamentally the same. When you're looking at artificial intelligence, whether you're looking at business intelligence, there are the data outputs that they have, the decisions that you make off of those outputs, they're really only as good as the data that goes into the system. So if you've got bad data feeding a BI report that a data analyst is creating, you're going to get bad output. The same goes for a data scientist who's building an artificial intelligence model. If they put bad data in, bad data is going to come out, and you're going to have missed opportunities. You're going to have wasted money on the project. You could potentially have lawsuits if you're exposing yourself to risk because you're using data that's not appropriate. So by kind of aligning what you're doing and building in that data intelligence kind of life cycle as you're developing the data before people start using it, that allows you to make sure that the data is trustworthy. It gives you a foundation of quality and governed data. Data intelligence really becomes a critical aspect of the process. It allows users to be able to gain context on the data that's being used so that they know they're using the right data. So good data leads to smart model decision making, and ultimately that's innovation and growth for your organization. So if we have that transparency through the data that's going in through the model, we're likely to be able to get to good decisions, good outcomes. And that leads to innovation, growth, money, if that's what you're looking for, and much, much more. Now there is definitely a difference between applying data intelligence to an AI or a machine learning model. It's a different type of information that you're organizing and structuring. You have to look at different types of metadata. Fortunately, there's people out there who have been thinking about this for quite some time. So there's there's places like Hugging Face where they've developed the model card templates that you can use. There's papers by Google that kind of laid this out a few years ago. And so by looking at these kind of standards, you can start to see some similar and consistent types of metadata that it's good to capture. So performance metrics, is your model drifting over time? How it's been trained, the methodology used in training it, what biases, limitations there might be, the model archetype. This kind of information can be documented and shared within your data intelligence platform. And if you have this model information in the platform as well, if I have information that says, hey, my model was trained on this training data, I can then link to that actual training data set where it sits within its repository, and we can see the full kind of lineage of information and data that's feeding into this model and its outputs. So we're looking again, kind of, we look at the AI model lifecycle. There's data discovery. This is the data ingestion point. We're searching through data to make sure that you find what you're looking for. All the different data sources can be centralized in your data intelligence platform. They can be curated so that you know that you're getting the right data for the right project. You can do data profiling. You can do data quality checks to make sure that the data is of good quality. It's fit for purpose. And then you have metadata versioning and traceability. Like I said, you can see you can do the lineage back to the data that's sourcing you. You can do lineage forward. So what the outputs for the model, if you're the outputs of your model are now become the inputs for my dashboard, my BI dashboard. I need to understand that where that data is coming from. So it helps you build that information lineage lifecycle as well. So you're really understanding how the data has been prepared. You can collaborate with other people and share that information and insights that you're deriving from your data. And you really do, you have that lineage, the governance, and that compliance aspect as well. And so all of these pieces put together, they're the same basic components are there, the same opportunities are there that you would find for more traditional data sets, if you want to call them that. It's a matter of assigning those knowledge principles that I kind of talked about earlier, those principles of knowledge organization, information organization, data curation, metadata management. It's a different type of object, it's a different type of process, but the basic principles are the same. And so to bring it back full circle to kind of what I'm trying to do right now and what we're doing with our data intelligence project is we're really trying to teach that method of thinking and that approach to students as they use our product in the classroom, or as maybe they don't use our product, maybe we just have a guest speaker that comes and talks. We've got a lot of different ways that we're interacting with people right now. And so we do have like several universities, primarily in the US, although we do have one UK university right now as well. And the students are using the product in different ways. Some data science programs, some are more traditional information science programs, some are also computer programs. Others are like information technology programs, people who'll be supporting the data products and the infrastructure and things like that. So a wide variety of use cases, but it's important for everyone across the entire data ecosystem to kind of have that same basic foundational level of understanding. And that's really what we're striving to do right now. And with that, I will thank you and see if there's any questions.
Hi, Susanna, can you hear me?
I can, yes.
Great. So this is Shruti. We have been working with Elation towards a breast cancer data catalog. And also, like you said, it feeds into the knowledge management system. So if you could just let us know about this very critical question about data quality, because in terms of large amount of text, like I believe you're doing that with some universities. So we have all these research articles with associated data. Now, if you have tens and thousands of these, how do you guys go about classifying them as worthy or not of keeping?
Yeah, that's a really good question. So by default, Elation is not necessarily doing a lot of sort of text analysis necessarily. So what we would do primarily is we would identify opportunities to work with, maybe another way to classify the information. We would ingest the output of that. We do have other tools that we use, like, for example, when in our management of the Help Center, we do some tools that do text analysis. We can do entity extraction that help us identify common topics and things. But as far as measuring the quality of text-based content, that's a little bit harder. Often what we've seen in the past has been more traditional data quality, where you're putting in different data quality-based business rules based on the timeliness or the different basic data quality dimensions of a data set itself. It's a little harder to evaluate the text itself. So I'm not sure I have a great answer for you on that piece, because it's a little bit outside of the scope of where we normally work.
Yeah, thanks a lot. Yeah, this is something I guess we will be thrashing it out amongst ourselves. One could be, of course, get it analyzed through a set of experts, field specific or subject specific, but still the data itself that is associated with this knowledge, that is something that we need to think about. But yeah, thanks for your answer.
Sure, yeah.
So my question is, what trends are shaping the future of data intelligence?
That's a great question. So some of the trends that we see right now, we are not different from any other industry. There's a huge amount of pressure to find ways to use generative AI and different forms of AI to improve the way that people curate and kind of manage their information. So how much time do people have to spend writing data curation definitions, data information, and how much of that can actually just be generated and then reviewed? So those are the kinds of things that we see quite a bit from our product perspective, right? In the way that people work. Data governance, as I mentioned, is becoming more automated because there's too much data for it to be effectively governed in ways that aren't automated. So how can you effectively scan data and classify it based on a certain set of rules or a certain set of assumptions once you've trained it off of another set of information? It's easy to do that for very highly structured things like, a vehicle identification number or an ID number, a government ID number, because those have very set and defined structures. But how do you start to do, even what Shruti's talking about, analysis of things that are a little more ephemeral, right? You don't really know how someone's using language in a way that will make something classified or sensitive or not. So you've got to sort of start to build those rules and that knowledge using essentially a combination of human in the loop in a lot of ways, manual classification and tagging and labeling of the training data. And then you also have to do some metadata as well. So once you've assigned that metadata, that has to be part of the input, and that has to be a feature that these models are using as they're evaluating things. So it's not necessarily just throwing everything in a large language model and letting it spit out different information for you. You have to build something that's a little bit more interactive, I guess, in it, open to feedback in the long term. It might not necessarily seem as magical, maybe as like a chat GPT that's going to give you a full data set description and documentation, but it's probably going to be a lot more specific and contextual to your organization and to the field of practice that you're in, because you can make sure that that particular model that you're using has been trained within your domain of expertise. So I think one of the things that I would say is like this domain level expertise of knowledge and starting to find ways to grasp that and train models on it and to build that and deliver that as a service within data intelligence is a huge opportunity that I see for the future. All right. Well, if anyone has any other questions, feel free to look me up on LinkedIn. I'd be happy to connect with you, or you can email me. My email address is here. And I'm be happy to talk to you anytime. Thank you for inviting me.
Thank you, ma'am. I hope this was an enriching and informative session for all of us. And once again, on behalf of the fraternity of Amity University, Uttar Pradesh, I thank all the guests and dignitaries for their significant presence. We would also like to thank all the students for their cooperation. And with this, we would like to conclude the session. Thank you.
Thank you.
Yeah, thank you so much, Shoshana, and special thanks to Anilji and Dr. Shruti for joining us. This data intelligence, I mean, it was, I would say that you have put the things very, very in a simple format, and it was in a format that could have been understandable by second year students as well, second year or the freshers students as well. So thank you so much for putting across the information in such a lucid manner, and look forward that someday we get more connected to work on such kind of project. Yeah, so this is for Mr. Anil. We are really excited and look forward to be working in this area.
Okay, thank you.
Thank you.
Professors, ladies and gentlemen, at the outset, I, Ananta Valli, express a warm and respectful welcome to the 14th International Conference, Confluence 2024, Cloud Computing, Data Science and Engineering, organized by the Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with a strong foundation and a platform for imperial inquisition. With this agenda, Confluence 2024 intends to bring together professionals, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovation and share results and new directions in the field of next-generation technologies. On the behalf of Amity University, Noida, we welcome a visionary leader and our speaker for today, Mr. Dan Isaacs. It's a great pleasure and honor to introduce our esteemed speaker. He has been a business development and management executive with over 20 years of experience in the field of semiconductor companies, including business development, contract negotiations, strategy, and product marketing focused on automotive technology driven markets, and is currently working as the Chief Technology Officer at Digital Twin Consortium, California. He is a distinguished figure whose knowledge and perspectives have made a lasting impact in his domain. Today, we are fortunate to receive valuable perspective from this outstanding individual regarding the subject of digital twin application in the industry and role of digital twin consortium. May I humbly invite you, sir, to illuminate this gathering with the plethora of knowledge, enriching our minds with the tapestry of wisdom. Please, sir.
Thank you very much for that kind and gracious introduction. And it's a pleasure for me and my honor to be able to present here to highlight what the Digital Twin Consortium is all about. So with that, in the interest of bandwidth, I am going to stop my video here and I will go right into sharing my screen. Okay, let me know if you can see my screen.
Yes, sir. It's visible.
Excellent. Just try and minimize this. All right, great. So again, thank you very much. My name is Dan Isaacs. I'm the CTO and the general manager for the Digital Twin Consortium. And many people don't realize, but we are part of an overall umbrella of organization under the Object Management Group. And the Object Management Group was founded over 30 years ago as a standards development, so a true standards development organization. And with that, they found that they were very good at bringing together companies to work together, collaborate in a safe and an IP-protected environment, and to work together to build out these standards that today many of the items you use and household items and electronics are built on those standards, whether it's system modeling language, unified modeling language, unified architecture framework, and that continues. There's over 200 members, large companies that are already part of the OMG and continues to grow and expand. And you can see here there are basically a total of 7 consortia under the umbrella of the Object Management organization. And it varies from the industry IoT side of things to the augmented reality at the Enterprise Alliance, to responsible compute, to software quality, to business process management, especially particular to health, as well as Digital Twin Consortium. And we'll focus on Digital Twin Consortium here. We're looking at it. This is from a forecast that just shows what the market projection is relative to software and services around digital twins. Expected to reach a global revenue by 2031 of over $180 billion. That's up from $9 billion projection in 2021. So that's pretty tremendous increase. And you can see here the breakdown. And this is based on analyst forecast, as well as some of the real world data that's coming back from some of our members and understanding that impact. And it's really interesting to note that over 40% of the forecasted revenue is looking at digital twin of organizations. And I think in the previous presentation, you heard about the importance of data and the data intelligence and looking at those different areas. And that really is the lifeblood of a digital twin. Data is critical. And we'll talk more about that and how that looks at from the origination of a digital twin all the way through its evolution towards intelligent digital twin. But what I wanted to show here was that the Digital Twin Consortium was founded a little over 3.5 years ago. And we had several different steering committees. We now have steering committee members. We now have a broad, diverse area, whether it's BP, whether it's Dell Technologies, one of the original founding members, as well as Northrop Grumman. And we have more announcements coming up, exciting about our steering committee member growth in the coming months. You can see here the plethora of the different types of industry members represented throughout, whether that's included from a geospatial expertise with Esri, whether it's Dassault Systems, whether it's most recently NTT Data has now joined, NEC, Mitsubishi Electronic, Google is a member, GE Electronic, Eli Lilly is also a recent member. So you can see just a huge cross-section, and this gives you an idea relative to these members, but it's also comprised of not just the technology providers, the researchers, and the academia, local government, but also we're talking about the end users. And just literally 2 years ago, I would not have been able to show this slide. We have had tremendous growth, and we continue to grow and experience and see that increased adoption across virtually every major industry. And here you can see representation within the consortium through either our direct members themselves or their end customers. So it covers a broad spectrum of applications, and now you can understand a little bit of why you see that type of a forecast within a 10-year period. And these end users really are the catalyst for being able to bring forward new examples and use cases that provide that transformative business outcome. So on top of our membership, we have multiple ways where we're expanding and really driving the growth of the ecosystem around digital twins to, as I said, accelerate these business outcomes, bring forward the thought leadership, the innovation, the industry use cases through best practices, innovation, as well as showcasing the value through these different real-world applications, and provide that guidance in terms of lessons learned. So companies and other areas don't have to experience those. We can accelerate that adoption of digital twins by leveraging the expertise, the depth, the breadth, and the practice of being able to develop, as well as implement, deploy, operate, and maintain digital twins throughout their life cycle. And another thing is being able to address the skills gap. We have a very strong academic and research working group comprised of many universities around the world. And you'll see some examples of those different areas. And looking at building out through these subject matter experts, a digital transformation academy of experts leveraging the knowledge and the collective intelligence of the consortium and its membership. But we also don't stop there. We have a regional branch extension, so our members that have very close ties in their specific regions of both to the local academia as well as the government, where many of the areas in terms of regulations, directives, mandates come out, as well as the incubators, the innovators, with many of these companies coming out of these universities or larger companies to go and bring forward their innovations. So you can see here, we now have pretty much a regional branch organizer, a member of the consortium in every major continent of the world. And we don't stop there. We also work directly with other alliances, other consortium, across a breadth of different applications. And one of the reasons I'm able to speak here is thanks to the graciousness and the opportunity that our liaison through Anil Srivastava, he's the lead of the Open Health Systems Laboratory, and that has opened up many different opportunities. And he is also the lead of our regional branch organizer for India. So much appreciation, much gratitude, Anil, for bringing these opportunities forward to the Digital Twin Consortium. So you can see just a tremendous amount of different areas and applications. One of these examples, the OPC Foundation, they have 800 companies as part of their foundation. And we work together and drive specific areas of focus, bring together through collaborative activities and joint working group where members can now cross-work together and share that knowledge and accelerate that adoption. So the mission here, you can see, is really to drive the development of digital twin technology, not just through the awareness and cutting through the hype of what a digital twin is all about, bring forward those foundational elements, but also look at it from being able to accelerate the market through real-world applications in partnership with industry, academia, government in this collaborative and open environment. There is an open source collaboration community that we have that's hosted on GitHub, and we have a advisory committee that reviews the different projects. That's also very strong in terms of the different areas. I encourage you to take a look if you've not seen Digital Twin Consortium site. It's at digitaltwinconsortium.org, and you'll be able to see a lot of these different areas. And some of the key focuses that we're looking at and challenges are in terms of interoperability. When you think about scaling from a smart building to a smart city, now you have so many different areas of focus, so many different data types. How do you ensure the interoperability, the data flow of those different areas together so you can now gain that actionable insight from these really system of systems, complex composite structures? Looking to accelerate the market through demonstrating those values. And one of those areas really is looking at how we can put the foundational elements of a digital twin. And if you think about it, and this is from one of our members, we looked at it in terms of what are those key areas. So here you have an example. This is actually a live wind farm at the time the data was taken. That's the true telemetry. So this is operating right now. You have a virtualization there to the right of the screen, the virtual environment of a physical entity and or process. Think about supply chain management or other areas, DevSecOps, these types of things. So you have that virtualization of a physical environment or process, but the key to this is that synchronization mechanism. And that synchronization mechanism allows the precision and the accuracy to be maintained between what's happening in quote unquote real time based on the physical to represent that accurately in the virtual. And what many people don't realize is that a true digital twin provides you a closed loop capability. In other words, that synchronization of data from the physical, that gives you that accuracy, that precision, that actionable insight to then be able to optimize the output in terms of the physical entity or that process. So if you think about that, I'm able to look at historical data. I'm able to look at the situational intelligence or the event intelligence, situational awareness in real time, quote unquote, and then be able to accurately and with the highest level of confidence, because I'm looking at it from a holistic perspective, optimize that outcome. Look at that from a standpoint of being able to predict. We had the chief technologist, the chief data science for digital transformation at NASA. She phrases this in terms of using hindsight with the insight, that real-time information, to then be able to, with that highest level of confidence, predict and forecast that outcome. So that would be the foresight. So hindsight combined with the insight to have that very accurate level in terms of having the foresight. Effectively, the digital twin is giving you that crystal ball. Now, what industry, what company wouldn't want a crystal ball to be able to predict their future? So again, the models, and this is looking at these key requirements. We have the models, so we have the synchronization, we have the real-time updates with that continuous data flow between the physical and virtual. We have the simulation aspect at that level of fidelity now to maintain that. But then it gets down to how can I visualize? How can I bring this forward in terms of an immersive experience and understand that? So the structure of the consortium is around working groups. We have essentially here 11 different working groups. And right in the middle of that is what we call our capabilities and technologies. When you saw those end users, you can see how they fit into those different, let's say the vertical or the domains in blue, the different areas there. But the horizontal area, that capability and technology, is where those fundamental areas such as security, such as trust. Again, the previous presentation, you heard how important that trust is of that data and the trustworthiness, which also brings in the fact of reliability. It brings in resiliency. It also brings in privacy, safety, functional safety, those different elements. So within this consortium, we're able to very much cross-collaborate between these different areas and bring these intelligence from these different working groups into this collective and understanding and knowledge, and really focus that in terms of the value. So again, very member-driven, very collaborative, results-oriented. You've seen the ecosystem expansion, both with the regional branch organization capability, with the liaisons and the relationships built there. So we can now establish these frameworks, these operating frameworks, and look at it, and how do I start my journey of a digital twin? Don't look at the data, don't look at the technology or the implementation itself. Look at it understanding in terms of what is the objective of that digital twin? What job am I hiring the digital twin for? And then look at it in terms of the capabilities necessary to perform that job. And as a result, this was through conversations with one of our members with their end customers, was be able to bring this forward in a very familiar format. And that structure is what we call our capabilities periodic table. Replace the elements of the periodic table with those capabilities grouped along the different specific areas, and then look at that in terms of composing that digital twin. We have a reference library of use cases and case studies that demonstrate that value across the different stages. And this is just representative of what we were talking about. This is actually a work product that we have generated and created a toolkit, and this is on our public site, but it really gives you that foundation to understand how to develop that digital twin, how do you start the journey, and then enable the teams across different areas to collaborate and accelerate their adoption. So this is where the toolkit is. This is public on our site. We've had thousands of downloads on this. It's become so popular, we created a subgroup to focus on that composability and extend this into the next levels in terms of what does a secondary version, what does the next layer of this look like? I talked about the academic and research working group. You can see here organized in terms of both training and certification, also publication activities, also research, and then collaborations. And from that, we can see how we can now be able to work to address the knowledge gap, the skills and workforce shortage through this awareness, through different partnerships, through different curriculums, syllabuses, as well as training and certification programs, different publications, as well as grants that we have in process right now across different areas. And we're actually working very closely in collaboration with some of the areas around the Leadership Alliance in one of the regions. This is in Southern California and Orange County. It's comprised of 60 CEOs that are now working together in conjunction to really look at how can we build this out and leverage the advantage of the talent in the area, and look at that from a perspective of cutting edge AI research. So there's a new supercompute center that has been just formulated through one of the universities. It's been supported through NVIDIA as well as through this specific area, and then bringing that forward in terms of now that thought leadership as part of that relationship. So some of the working group activities, deliverables, many of these are already in stages where we have them posted on our website. There's a wealth of information. We're actually now working and completing the final stages of a book through Springer Nature, and it's based on the work product coming out of the consortium. It's the membership and their activities to bring that insight and those best practices forward. In other areas, we have our reference library, what I called about our technology showcase, where here is an example in quality control in industrial manufacturing. You can see here what's happening in terms of being able to identify very quickly where there are potentials for defects based on the annealing process, what's going on with this with these laser controlled situations. And this is in a automotive manufacturer supply for crankshafts and other engine and other related material. And here you can see the digital twin, then you can see the physical output. We also have what we call our technology spotlight, and being able to highlight any new member that joins now has the ability to bring forward what their core competencies are. From that, we look at that, it opens up to the members, they start collaborating, and then that develops and turns into further use cases. So these are on our site right now, public. You can see, I think there's probably 8 of these that we have published now, and it talks about what is the role, what is the objective, And how does the digital twin in this application bring forward that transformative outcome in terms of the value recognized? So while we have a whole series of these already published, you can see some examples. We have quite a few in the queue in terms of the other ones that are in process right now at various stages. So the goal is every 3 to 4 weeks, we release a new significant use case or case study demonstrating that value. Here's one example, one of our most recent, which is using digital twins in public safety. So there you can see the objective, the value, and what the role is of that digital twin. You can actually download the material and understand that use case better once you register. So we drink our own Kool-Aid. The work product coming out of this consortium, we've now molded or built into this work stream that allows us a consistency in how we bring forward these different types of use cases. And I'll show a little bit more detail in this one in particular. This is digital twin in healthcare and life sciences. You know, one of the areas and topics here we're talking about are some of the applications. This is a member who is working with the largest hospital in Singapore, and they're looking at it from being able to track the level of viral dispersion within the different wards in the hospitals. So being able to look at this from both a detection, a protection, so how fast can we quarantine? How can we really minimize the type of a contagion that might happen? Whereas before it went through the hospitals and all through these different areas, and we saw that very, very rampant during the pandemic. Now being able to use a digital twin to give you that instant notification and alert to be able to contain and minimize the effect of that contagion and even prevent an outbreak going forward throughout as the patients or the staff leaving the hospital now brings that exposure forward. So this is something that is operational right now, and it's in its stages of proof of value. At this hospital, there's a link to talk about how they use the digital twin there. I highly encourage you to take a look at that. This has actually got the attention and has been written up through the Mayo Clinic proceedings in terms of using this digital twin to be able to look at that as a surveillance system and be able to minimize that impact. Keeping on the lines of the healthcare, this is from one of our members. This is Eli Lilly, looking at this in terms of driving what it's calling the smart medtech, this disruptive ability that digital twins bring in terms of digital transformation for both healthcare and pharma. And you can see some of the key drivers here. See some of the areas, and you also notice the that visualization of that intelligence through the VR, the virtual reality, the augmented reality, the different types of mixed modes in these areas. And you can see, looking at that, as an event that highlighted, I really thought was a key point brought out. Possible to abbreviate a traditional 10-year process to 10 months, being able to have that understanding. And that leads us really towards the evolution of the digital twin, where we have gone from a traditional digital twin to the role of now expanding that into the intelligent digital twin. So what do I mean by that? But looking at this is from a pivotal paper written by Dr. Michael Greaves. He is the founder or the father of the concept of digital twin. He actually wrote a paper in the early 2000s where digital twins have been growing up and being utilized, and that was in manufacturing as well as in aerospace and defense. And he was talking about this from a product lifecycle management perspective. You can actually download the paper at ResearchGate, his original paper. But what he's done is since then now built that out quite a bit in terms of leveraging the real advantages and the values that digital twins have provided. So here you can see sort of from the early stages with that traditional twin, traditional approach, now moving that forward and bringing that forward in terms of the key importance of having that synchronization mechanism from the virtual to the physical, and then being able to now move that into what he's calling the intelligent, or what has been labeled the intelligent digital twin. That's that IDT platform, intelligent digital twin. So what does that really mean? What does that transition look like? And again, this is based on that paper that he has written. It's the most downloaded paper on ResearchGate with over thousands of downloads around digital twin. And you can see here where you understand that the traditional digital twin is looking at it where we have directed it when to activate based on detecting an anomaly. So looking at that data, that actionable insight, we've said, okay, that's anomalous behavior, let's inform. But it's always waiting for that anomaly to occur. So that's where it's really more offline. It's more passive in terms of the overall focus. And we've told it what to look for. And that's great. We've been able to show, yes, we'll predict when this happens so we could prevent unplanned downtime, other scenarios, but it's not really looking at it in terms of optimizing. Now let's progress forward in terms of the intelligent digital twin. You have these agents that are always monitoring. You're always online in that quote unquote real time. You're always scanning, you're looking to actuate. So instead of being told what goal we're looking for, it's actually seeking the different areas where it can now anticipate based on these different scenarios and inform. And actually, as we move forward in the intelligent digital twin, we're at the early stages here, but it could be able to autonomously take action. And it's looking at it from a different perspective, this concept of FRS. So we show how on the traditional twin, we're looking at the data, right? It's the data, as you heard again in the previous presentation, it's about supporting decision through understanding of that data. What is that actionable insight? Whereas with the intelligent digital twin, you've now transitioned to a data flow. You're being able to look at that in the context of the real-time data and advance the understanding by running your model, your virtualization faster than real-time. And that's what this FRS stands for, is front-running simulation. This is an example where you can see it in the F1 racing. So here it's this data-driven innovation here. This is probably the fastest and the largest digital twin in the world. There are processed in terms of telemetry points, 1.1 million telemetry points per second are transmitted from the cars to the operating to the pits there. This real-time data is then combined, again, that historical, that holistic view, looking at it from a historical perspective to a situational awareness, the event intelligence you're gaining from that 1.1 telemetry data point per second, and then being able to predict and actually optimize that outcome. How can I then outperform the other vehicles there? And really interesting is they actually have a digital twin of the raceway, of the track itself, and they know, and they've already analyzed that, and they understand that down to the best way for the vehicle, for the race car, to then manipulate and change and perform in that area. So it's pretty incredible what they're doing. There is a case study. This is, as you can see down at the bottom, how they're working together through AWS. And it starts with the data. Again, I was telling you, the data is the lifeblood of the digital twin. And every F1 car you can see has over 300 sensors generating that type of a data. And that analysis, that real-time data being analyzed, understood. Now look at what the types of use cases that come out of that. The analysis, that feedback can now bring in the next generation of performance from the new car developments. Understand that, and based on the drivers, based on the different vehicle areas and the different components. Now extrapolate that into an industry, into a manufacturing center, extrapolate that into a multiple manufacturing sites, and being able to have that comparison to then understand very quickly where your optimizations can be occurring from, whether it's energy consumption, whether it's water, whether it's waste, whether it's the productivity. Why does one assembly line have a better output than the other? That's what that digital twin is giving you. It's giving you that ability to have that crystal ball to be able to optimize to the best level. So back to the evolution. Here's your traditional digital twin, just we talked about those characteristics: offline, goal-driven, predictive, but not optimizing. And now what happens as we reach the intelligent digital twin, and this is through one of our members bringing this forward, what we're doing is we're changing the decision management. We're bringing that expert knowledge. We're bringing these business cases, the conventional artificial intelligence and machine learning, but now we're bringing in the generative AI aspect of that with the large language models, bringing in the neural networks, the deep learning. Now we become goal-seeking, leveraging that real-time intelligence to run those models faster than real-time, do that analysis to optimize the outcome. So what we're seeing is the decision management is changing very quickly in these intelligent digital twins. So we're evolving from the traditional to these intelligent digital twins, where we go from a decision support to augmentation of that decision to then, as I was saying, going forward in terms of more autonomy, where we have decision automation. And that's really where this consortium is continuing to bring forward these evolutionary changes and what we're seeing to advance both through innovation, the business outcomes, through the innovation, through the collaboration with this collective intelligence, to be able to bring forward the thought leadership and the expansion of the opportunities to continue to drive that ever-critical ecosystem. And you can see here on one axis, looking at it from increased member activity. I talked about the open source collaboration. I talked about the working groups, the thought leadership, the regional branch organizations. On the other side, you can see the ecosystem expansion and adoption and driving that forward. Again, I encourage you to take a look at the digitaltwinconsortium.org on our website. If you have not seen, a lot of the material I've shown is there, and there's quite a bit more in terms of being able to understand the value as we progress that digital twins provide. So at that point, I want to thank you very much for your attention, and we'll open it up for questions. All right, that means I did a great job explaining, and you really understand the foundations of digital twins. So thank you very much, and really appreciate your time and the opportunity to present.
Sir, I have one question.
Certainly.
So what are the potential ethical concerns surrounding the use of digital twins, especially in the sensitive areas like healthcare and defense?
I'm sorry, could you repeat?
So what are the potential ethical concerns surrounding the use of digital twins, especially in sensitive areas like healthcare and defense?
Absolutely. And I think you saw that from the previous presentation also. You know, as you look at the fundamental areas in terms of the core enablers of digital twin, which is looking at it in terms of being able to access the data, being able to have the understanding and the actionable insight, you need to be able to get access to that data. That opens up threat thresholds. You then need to be able to look at that in the context of, how do I actually understand what that data is telling me? How do I run those analytics and understand that? Now, if you're talking about generative AI, that opens up a whole new can of issues. So I think that if we look at it from the security and the trust, that is the foundational aspect of the digital twin. And so looking across it in terms of also storing that data, how do you do that in a secure environment? How do you get to a point, and we didn't talk about this, but really the digital thread, that single source of truth, how do you bring that forward? That's where technologies such as blockchain and other aspects come into play in those areas. But it's really not just limited into those specific areas, but it's across the board. You have to have the trust of that data to build a true foundation that has that ability for security. It has that ability for resiliency, for reliability. And especially in the case of GDPR and the case of the privacy of the data, when you look at it from a healthcare standpoint, that becomes even more paramount.
Thank you, sir. Thank you, sir, for your insightful words. With this, we conclude the session. Mr. Isaacs captivated us with profound insights and thought-provoking ideas throughout this keynote session. We have embarked on a journey on intellectual exploration, gaining a deeper understanding of the topic data twin and its implications in various industries. Our sincere gratitude to Mr. Isaacs for sharing expertise, passion, and commitment to data twin field. May the seeds of knowledge sown today flourish, shaping a future where curiosity knows no bounds, and innovation knows no limit. Thank you for being a beacon of inspiration, and may the ripples of this enlightening session create positive change in our academic and professional pursuit. We hope that it was an enriching and an informative experience. I once again, on behalf of Fraternity of Amity University, Uttar Pradesh, thank the guests and dignitaries for their significant presence. We would also like to thank the audience for their cooperation. Thank you, sir.
Thank you very much.
A very good afternoon to all the distinguished dignitaries, respected professors, ladies and gentlemen, and fellow students. At the outset, I, Himnish A, express a warm and respectful welcome to the 14th International Conference 2024, Cloud Computing, Data Science and Engineering, organized by the Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with a strong foundation and a platform for the empirical inquisition. With this agenda, Confluence 2024 intends to bring together professionals, academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and various innovations, share research results, and new direction in the field of the next generation technology. Now, it is a privilege and honor to have among us Mr. Raghavendra Bhatt, Principal Engineer, Intel Corporation. Sir is an accomplished individual having over 24 years of industry experience spread across domains like vision AI, NLP, embedded platform, development for mobile, automotive, and biometric solutions, and network management. Also, as a part of IEEE standard organization, he co-chaired the pre-standardization study for low-resourced Indian languages. Currently, Sir is the exploration lead in the retail and healthcare space as a part of the vertical solution and services group at Intel. Sir has also contributed to the iris biometric device development and specifying device security requirements. An esteemed figure with significant knowledge and perspectives that have made a lasting impact, we are today fortunate enough to receive valuable insights from this outstanding individual on the topic of trust access, a global public-private partnership, architecture, and OpenFL, an open source framework for federal learning. On behalf of Amity University, Noida, sir, we extend a very warm welcome to our speaker today.
Yeah, thank you. Thank you very much for the warm introduction. I thank Amity for giving me this opportunity to come in and talk to the audience there. I also thank Anil, OHSL, for giving me this opportunity, and Dr. Madhuri for helping with all the required details for me to dial in and share this knowledge with the students there. So what I'm going to talk about today, I mean, as the title says, addressing data challenges of healthcare industry. And while the first part of the presentation, I will talk a little bit about what are those challenges, why are they challenges, and how do they manifest itself in the industry. And then I'll get into talking about trust access, which is an attempt together with, mainly led by OHSL and Intel being a collaborator from a technology perspective, which is an attempt to kind of address it through a public-private partnership, bringing in all the ecosystem stakeholders together to address those data challenges. So with that, I'll just start first highlighting, painting a picture of, what are those challenges that we have in the okay, just a minute. I'm not able to move. Okay. Yeah. So what are those challenges when it comes to the healthcare data, right? So all of us do recognize that, healthcare from a data perspective is not poor. We do have enough data going around. But unfortunately, and I mean, when I say unfortunately, this is more from a technology perspective, right? All of the data happens to be in silos. What I mean by silos is, today you walk into hospital, your scan reports, your lab records, all of the data is available with the respective hospital. But just that, it continues to remain in that hospital and not really accessible to, say, for example, an organization which is developing AI algorithms. It's not easily available to such organizations to develop technology itself. So point is, data is there, but the fact that it remains in silos means that it's not accessible and available to the technology world, right? That's the first part of it. The other part of it is also, even if you have access to the data, even if the technology industry has access to the data, a lot of the data is unstructured, which means that we cannot consume the data immediately. There has to be a lot of work on that data before, say, your AI algorithms can start consuming that data. And these two problem statements are manifested, to an extent that they now kind of contribute to each other in a very symbiotic way, right? The silos lead to that unstructured data. Unstructured data is also a barrier towards opening up of data by some of these organizations. They may be ready, but fact that their data is not clean and ready for consumption means that there are not many takers for that. And that in turn, so what are the key contributing reasons for them? I'm not going to touch upon each one of these contributing factors given the time, right? Some of them are pretty self-explanatory, like privacy regulations, etc. Right? There are those, country-specific privacy and regulatory requirements which determine as to how you can share the data. But even within the boundaries of a nation, for example, in the Indian context, right? Why is the data sharing not happening? So you have those challenges with respect to data value. All the institutions recognize that data is monetizable, so they are not that forthcoming when it comes to just go share the data, right? Unless until there is a government-sponsored initiative which kind of pays them or rewards these institutions for sharing the data, the motivation to share the data is less until they are confident that that data is priced and monetized appropriately. Then, of course, you have the challenges with respect to the data size, because so if in case you want to aggregate the data on the cloud, just the movement of the data from respective hospital infrastructure, the storage that the hospital may have to the cloud, it's not an easy job. It's a costly plus not a time-consuming affair. The last one is how do you, from a technology world perspective, how do they even know which hospital to approach for the data, right? The data discovery. It's not that all data is useful. So there are specific kinds of data, based on the medical condition or the research area, the specific kinds of data that you're looking for. So how do you discover the data and then go approach the hospital or the institution and then get the access to the data, right? So the data discovery means that, a lot of the data, because it's in silo, continues to remain in silos. On the unstructured side, again, touching upon a few, the lack of standards, as in, there's no consistent format defined for each kind of data that's generated in the hospital, right? To an extent, the imaging data, you have a standard, for example, the image standards come in there and you can use it. But when it comes to the data quality, the EMR, the HIS systems, it boils down to the medical systems in terms of, what data schema is used, is it easily accessible, right? So the point is, at the end of the day, the different medical systems, the quality of the data. For example, a lot of EMR, the doctor's prescription is written by doctors, right? How do you convert it into a digital format? There is a challenge with respect to deciphering that handwriting, right? And then basically make it available for the others to understand as to what the doctors prescribe for a given patient. So just as an example of the data quality, right? For example, in the West, NHS and IH, in UK, in US, so the doctors also have some audio system with them, which kind of records, whatever they are saying, they can record for a given patient, all the details, and that is easily digitizable, as we all know. But in the Indian context, for example, the data quality also is a suspect. And lastly, the two on the emerging multimodal usage. So today, AI has become powerful enough that I can combine video, audio, image data, audio data, text data together. With large language models, for example, and I can make a lot more better sense with the context that the multimodal data provides, right? So how do I combine, right? So today I have access for maybe only EMR. I have access only for imaging, the scans or the X-rays, right? But if in case I want to combine all of that, how do I do it? So that also kind of contributes in the context of, maybe the image data is understandable for the AI model because its image and standards are fairly known. But for the text and others, it becomes a bit of a challenge, right? So all of these are contributing factors, and from a technology perspective, this is what it leads to, right? In terms of the algorithms, accuracy, the bias that kicks in. A lot of algorithms today, when they're developed, they perform exceedingly well in lab conditions. The first deployment, the accuracy goes down, for the simple reason that it's not been validated for a real world deployment. It's validated on a test sample data set, but not exactly in the real world condition. Right, so contributes to some of those other challenges there, right? So just to some of the challenges that I listed, I mean, how does it manifest itself in terms of numbers? This is just an example, small snippets of some of those problem statements, right? 97% of the healthcare data today is unused, right? And this is a pan-global view, right? And that actually is a very damning statement, because there is so much of data that can potentially be used to cut down on your drug development lifetimes. It can be can be used to develop precision medicines, etc. But you cannot tap into the potential of data for those challenges that I talked about in the earlier slide, right? 97% of the healthcare data is unused. Every data breach, there's other problem with respect to the privacy and, the costs associated with protecting patients' privacy, right? So even where the access is given, it is given in a way that privacy is compromised, right? And every breach of data, every breach is potentially 9.2 million. It's 2021 data. The value only goes up, right? It will not go down. With respect to the multiple medical systems contributing to the unstructured nature of the data, 24%, less than 24% of the data matched. So for example, if I have developed an algorithm, the chances are that only 24% of the data that is accessible to me can be understood by my algorithm, because the remaining data, I have to still spend some time to understand the schema and then ensure that the algorithm is able to understand the data and then feed the data in. And the last one, with respect to the data quality overall, 50%, 56% of the hospitals lack data governance, right? So, I mean, just a small illustration of, the magnitude of the problem statement that we're looking at when it comes to data challenges. But all of it put together, the point that I want to make here is, there is a significant challenge when it comes to being able to access data to develop, some of those technologies required to solve the medical, the health care problem statements. So how do you address that problem statement, right? How do you address the data challenge problem statement? Essentially, there are two parts to it, right? This is not something that is, only I am saying that this is the problem. This is how you address the problem statement. This is well recognized, right? There have been numerous attempts to also to kind of come in and address this in using these two vectors, the data consortium and a proper way to handle data. But the scale is a problem statement. How do I do it at scale? I can do it, in a small limited setup, in a pilot setup, but how do I do it at scale has been a consistent problem statement. So there are two broad components to that problems, to that solution space. One is the data consortium, wherein you get together all those healthcare partners, the hospitals, the laboratories, some of the government institutions which have the data, bring them all together to be able to provide the data and also bring the data consumers at the other end. And the other one is with respect to the technology to make that data that is available as part of the consortium easily accessible and consumable by the technology components. Right. So and the handshake between the two is what gives you a rich data consortium. And that's what Trust Axis is all about. And I'll get into Trust Axis in a bit. But just to double click on data consortium, right, what does it include? And you have the data providers, as I said, the healthcare providers, life science, pharma companies, research and academia, could be private, could be public institutions. Right. And on the other end, you have the data consumers who want that data. Right. And then the consortium in between, which is kind of connecting the two, the providers and the consumers to unlock the value from the different sectors as well as across multiple geographies, right? Because ideally you don't want to limit. For example, drug discovery today is not happening at a very country-specific level. Drugs are made at a global level, but then there are clinical trials at every geo-specific basis to kind of see the efficacy of the drug, right? So the point is, a consortium has to kind of be able to cut across the geographies, across multiple sectors. And when I say sectors, health sectors. And that's what this consortium should, a consortium should be able to address, right? And the data mesh model, again, that's a technology piece part, and I'll cover that in the subsequent foil. But the data mesh is the underlying, secret sauce, to, if I may put it that way, to solve the problem statement with respect to the data qualities. On the data handling itself, on the data handling, there are around 7 vectors in terms of management of data when it comes to storage. Consent management is extremely important. A lot of regulatory policies coming in, recognizing the patient's right to their data, and ensuring that usage of patient's data is only based on certain consent. And consent can be multi-level, patient, then the institution, at which the patient is, and then at an higher level in terms of, maybe the geographic boundaries, etc. Right? So if you are sharing data, India population data with somebody outside of India, then the governments can kind of put some condition, right? The consent can be multiple level, patient to at a country level. Then the quality of the data is, as I spoke before, that's a challenge. Data redundancy, the backup, right? When it comes to storage, redundancy is a natural requirement. Securing data and compliance to regulation, all the data that is curated and made available as part of the consortium should be conforming to all those regulations across all the geos the consortium is participating in, right? Sharing and seamless exchange of data, sharing and okay, now the sharing part also, there are two elements to it, which I'll talk about in subsequent foil. Sharing does not necessarily mean that you have to copy data to another location, right? You can also do data sharing without copying the data, which actually helps on the regulatory side, privacy regulatory side. And finally, when it comes to retention, compliance, archival, and purge. So this entire data handling, needs to be provided as a consistent solution, which ensures that, whoever participate in that consortium, all of their data is available in a consistent manner for the data consumers to consume and develop, the health tech companies, clinical research firms, research academy, hospitals, right? Then they can consume it in a very consistent way. Now, trust axis is that, is a data consortium kind of I shouldn't call it data consortium alone, because that's one big element of what a consortium should do. The trust axis that OHSL is leading, and Intel being a technology partner there. The intention is, think of it this way, right? And I'll up level it a little bit here. So I talked about the data challenges, right? But then there are also the researchers, and then there are researchers sitting across the multiple locations across the world. So researchers, who need access to the data, also need access to the right kind of a compute. For example, genome sequencing is not something that everybody can do, right? It does require a certain kind of HPC infrastructure to be able to use it, right? Then a lot of these new data types, again, genome is a good example, as a requirement on some of the tools, right? So the idea behind this alliance, trust axis, is, in addition to addressing the data challenge, can we also address the compute and the tools challenge, right? So the idea is to set up that corridor. Think of it like a highway that connects the researchers with the necessary tools, data and compute, to be able to come up with collaborative healthcare innovation for impactful results. So that's the trust, the motivation and the vision of why trust axis is formed, etc. So just to kind of get into a little bit more details, and these are the key components of trust axis. I have spoken about data store, which is with respect to the data providers, right? So connecting them with the data consumers, right? So that part I've already spoken about, right? But the key one also is on the compute and the tools, right? And compute and the tools, so a lot of the technology pieces that is required to consume the data comes there with respect to transformation, discovery, publish, analytics, ingestion, etc. And there are also those tools with respect to, of course, with helping with those data operations, but as well as understanding some of those new data types like genome sequencing, for example, right? Security and trust. Now, this is extremely important because, technology normally, when we talk about innovation, it all normally leads to some IPs being created. Now, how do you protect those IPs, right? Because when you're creating a consortium, a public-private partnership of a consortium, everybody wants to participate, but if the IPs are not secured, then the motivation to kind of, make that consortium a meaningful affair is pretty less, right? So security and trust comes in mainly from an IP perspective, but then there is also the privacy. How do patients feel confident that their privacy is not compromised, right? And again, security and trust comes into that element. Quality of service and service intelligence, there's the entire business logic of it that comes in, because consortium, if a consortium kind of comes together and it has to sustain by itself, it cannot just be about, doing it for public good. we also do need to understand, recognize that there is a data monetization, there is a profit motivation for some of the participants to come in. I mean, for example, a hospital which has spent a lot of money curating data, creating quality data, why would they give away their data for free, right? So they do need a mechanism to kind of monetize on that data. And that's where the business logic and the service intelligence, data governance comes in. And last but not the least, the high performance computing, extremely critical for us, because without the HPC infrastructure, a lot of the work cannot happen given the state of affairs in technology today, AI and others. Now, a little bit on the technology. So that's on the alliance, the ecosystem part of it, right? The trust tax is what is the motivation, what we're trying to do. I mean, I could have talked about a little bit more detail in terms of what the participants, etc. But in interest of time, I'm just keeping it at a little bit of an eye-level overview. And right, so I'll get into the technology piece of it. For data management, so you do need a mechanism to handle unstructured data. And that's where, again, technology is available today, NLP. I mean, if you go to, for example, there are a few large language models being done in the healthcare space. And today they are also getting into a multimodal wherein they're able to combine the image and text, for example, right? But the key thing is, and I can use at a very minimum, I can use some of those LLMs, NLP capabilities to convert unstructured data to structured data. To kind of even language translations I can do, right? Because when I'm talking about a multi-geo kind of consortium, I should also be able to handle multiple languages. OCR conversion, right? I mean, that's one critical requirement, with all of this data. So because you might get an image and of a doctor's prescription as a photo, how do you convert it into a digital format? The second one is, how do you ensure that, the consent management, the data ownership, how do you respect the data ownership? Right. The third one is, even if data is available in a distributed environment, each hospital having its own data, etc. How do you kind of, enable access to the data without necessarily copying the data to a central location, right? Of course, I do recognize that, and we do need to recognize that there is a lot of effort underway, mainly sponsored by governments across the world, to create some of those data corpus. But the point is, as new medical conditions coming in, more data coming in, you do need a mechanism wherein, while you absolutely need to provide for accessing some of those central repositories of data, you also do need to provide a mechanism to be able to access data, from where they're originated, right? Hospitals, and also that also has an element of additional privacy guarantees. So distributed data in silos, extremely important for us to address that. And then the last two, with respect to the data governance and security, I talked about that in a little bit detail. And the last one is, what I talked about also with respect to minimal to no data movement, right? Which is actually a growing requirement when it comes to some of those regulatory privacy considerations, as well as the data value, right? Hospitals do not want to move the data to somebody else if, they're not very sure of whether all the value in the data has been tapped into. Right. So, I mean, at some level, an analogy I will give you, so data is like your sugar cane, right? I mean, whether in one part of the sugar cane, the whatever juice you've extracted, is it the only juice that's available in data, or can you kind of use the data for multiple other use cases? And that's why, the data value is not easily quantifiable. I cannot say X-ray, okay, this is what it is, right? Because chest X-rays, this is what it is. Because I can multimodal, multi-condition, multiple sectors coming together, looking at X-ray in combination with something else. The same X-ray can be also be used for something else, not just for COVID, but also for maybe for some tuberculosis related. And as medical science improves, maybe a lot more use cases. So a little bit on the data silos, from a technology perspective, how do I get access to data without needing to move data to various locations? So one mechanism to do that is a data mesh architecture, right? Wherein you have those different nodes. Think of the nodes as hospitals, with their data repositories. So they're not exactly moving the data there, data outside of the hospitals. So in a way, you are looking at them as data as a product, right? So whatever data they have, they're kind of converting that into a product to be consumed by others, by the consumers, data consumers, right? So each of those nodes, you can look at it as the hospitals. And then there are those data users there whom you can look at them as the consumers of data, right? The pharma companies who want to know, the profile of patients for a clinical trial, for example. Right. So you do need a mechanism to combine them all, bring them all together. And that's where the block in the middle, the data consortium, comes in, and you create a sort of a mesh to connect all of these disparate entities, right? And the intention behind, is what I talked about in the earlier foils with respect to, ownership and ensuring data as a product. You do the necessary qualification of the data and then treat it as, an end product. Data infrastructure and data governance. Data infrastructure also is important because, as data I mean, if you remember one of those numbers that I put up in the second foil, 56% of the hospital do not have a data governance infrastructure. Right. So self-serve data infrastructure is also helping address some of those gaps and ensuring that hospitals, when they subscribe to this infrastructure, they get an infrastructure that ensures a certain basic quality of data. Right. So how do I instantiate the data mesh? So we have defined, as part of trust access, we have defined a broad architecture which allows you to combine all of them in this mesh kind of a network. But again, interest of time, I cannot get into each one of those. I just picked on one element which is pretty critical, which is the federated learning piece. Right now, this is a technology that has come in, and it's a methodology, I would say, which is mainly used to ensure that you are able to access data without needing to move the data. Right. So instead of moving the data to where the compute is, you move the compute to where the data is. Right. So the idea is you have compute at each of those, say, hospitals, for example, and you move the AI model to. So that's what you will see in the animation. You move the AI model to those hospitals, train locally, get it back to that aggregator where you combine the individually trained model into one single global model, right? Now, this actually brings in a lot of requirements around, I mean, it addresses the data silo for sure, because, now you don't need to move the data out of the hospitals. Data continues to be at respective hospitals, conforming to all the privacy regulatory requirements. But what about, how do you ensure that, there's no spurious entity coming in and copying data? How do you ensure that there's no spurious entity at each, so some of those hospitals, leaking the AI model secrets, right? Because AI model is an IP of the company which is developing it, right? How do you ensure that? That's where the security aspects come in, because you do need to create, for example, a trusted environment, trusted execution environment within which you execute access to the data, as well as the training loop itself, right? So federated learning as a methodology is able to address all of those requirements. And and Intel has, and this is an example of how powerful it is, right? I mean, this methodology. So Intel has run in partnership with UPenn in the US. So we have run the world's largest healthcare federation, right? So we've looked at brain tumor. So there's not much of public data available on brain tumor. So the idea is, so we signed up, together with UPenn, around 71 sites across 6 continents. We all, came together, defined the tool chain with respect to the data management, cleaning up of the brain tumor data, etc. And that data was made available. Right, and then you train that data, right? And there are a little bit more details there, as the legend shows you, with respect to, the initial model, where it came from, where all the training happened, the federated training, right? Which of those sites had out of sample data, because you do need to validate, right? Because if and that's one of the powerful advantages with methodology like federated learning, that you kind of get access to a lot more data which may not fall into a certain distribution that you've trained on, right? So that's what makes it that much more robust to real world deployment. Right. So out of sample validation, and then the aggregation server. So we had the aggregation server in one location, UPenn, right? But then there have been participating entities all over the geos, right? Even in India, if you see, there were 2 entities which participated, right? TIFS, I think, was one of them. So as a consequence, what happened, right? Remember, a lot of that data that was there in those 71 institutions would not be available, would not be accessible without a federated learning kind of an infrastructure, right? So as a consequence, because you have access to more data, right? So you have a gain of up to 33% on local validation data, right? Which means that your algorithm is becoming that much more robust to any unseen data in the real world, right? And 27%, 27% is on that out of sample, right? Which is that robustness that I talked about. So and the paper link and all is provided in the slide deck, and which I will share. But essentially the point is, it's not only getting access to that data and as a consequence of the homogenization of the data, but it's also the fact that you have made the AI model that much more robust to real world deployment. Right. So the technology, the component which actually does that is OpenFL. Started within Intel. Now it's part of the Linux Foundation. So this one is an implementation of federated learning. But the key one for me here is not just with respect to the learning, but also the fact that it also creates that secure infrastructure highway connecting all those participating institutes so that I can actually share, not just the data, but also the compute and all the tool chains, right? So that the network connectivity that it creates is also equally powerful, in addition to the federated learning, the training piece of it that it allows for, right? That it provides. So, I mean, again, I think there are links given at the bottom with respect to, where you can access OpenFL from. It is model agnostic. I can do any one of those Keras, TensorFlow, PyTorch. In fact, we've extended it to also cover JAX with Flax extensions. Right. So that way it's not tied to any framework. I can open source, of course, because it's part of Linux Foundation. There's a GitHub link given there. And you have a direct barebone metal installation you can do, as well as a Docker image that you can pull. Right. So Trust Access does use this component, the federated learning piece and OpenFL, to create that powerful mechanism to train without needing to move the data, as well as create that infrastructure to be able to share, exchange your compute, your tools, and your data on that infrastructure. Right. So with that, I am done. I hope I give a quick overview of what it is. So there is as I said earlier, there's a detailed architecture foils, that are there, but just in interest of time, I couldn't cover that, right? So I'll pause and I'll take any questions. So then thank you. I think, thank you for this opportunity. And if it's okay, I will drop.
Thank you from our side, sir, for also bestowing us with such valuable knowledge, sir. It's truly been a pleasure to having you at this afternoon. Thank you, sir.
Thank you.
So with this, we conclude the session. We hope that it was an enriching and informative experience. I once again, on behalf of the fraternity of Amity University, Uttar Pradesh, thank all the guests and dignitaries for their significant presence. We'd also like to thank the students for their cooperation. Thank you so much.